Okay, everybody, this is our last section. We've come to the end of the series. We're going to talk about pacemakers because they can have specific signatures that you need to recognize on the wards. And here's a list of pacemaker ECGs that we're going to cover. We'll start with atrial and ventricular pacing, and then we'll look at AV sequential pacing, and then biventricular pacing. So here's our first pacemaker tracing, atrial pacing. First, you will notice a sharp spike that comes before every P wave. This spike is the sign that a pacemaker is firing. In this example, the pacemaker spike is really obvious, but in other ECGs it might be subtle, so you'll always need to be on the lookout. Notice how after each spike is a small deflection in the P wave. You can see how flat the P wave is in this example. The reason for this is that the atria are diseased to begin with. So the sick atria throw off less voltage than they would if they were healthy. On this ECG, we know that AV nodal conduction is relatively healthy because each atrial paced beat has both a P wave and then a QRS wave following. So using inductive reasoning, the patient most likely had the pacemaker placed due to sick sinus syndrome involving the sinoatrial node. Okay, so now let's take a look at ventricular pacing. Many people who have pacemakers have two pacemaker leads, one in the right atrium, one in the right ventricle. The reason for this is if a patient has conduction system disease, it's less likely to be due to some isolated sinus node disease alone. Usually there are other parts of the conduction system, such as the AV node and the bundle of His or the bundle branches, that are also exhibiting some disease conduction as well. And so the pacemaker is a true electrical bypass of the AV node, and the ventricular lead paces the right ventricle. In this ECG, you can see that a pacemaker spike falls right at the very beginning of the QRS. And you notice that the QRS is wide, and this width is because instead of conducting rapidly down the native conduction system, the paced electrical impulse has to tread slowly from myocyte to myocyte, and so it takes longer and is registered on the ECG as a wide QRS. Also notice the direction of depolarization. The QRS is downward in the inferior leads 2, 3, and AV foot. This means that the origin of the impulse happened inferiorly near the apex of the heart, where the right ventricular lead is inserted into the right ventricle. And look at lead V1, which has a left bundle branch morphology. This means that pacing was happening in the opposite chamber, the right ventricle, because right ventricular activation happened first from pacing. And this is similar to how the right ventricle would be activated if a patient had left bundle branch block and then the electrical signal first went down the right bundle branch and then into the left side of the heart. Also, look at the lateral leads, lead 1 and AVL. We see a positive QRS wave. And this is because the impulse starts in the right ventricle and then goes to the lateral wall of the left ventricle. So the direction is up and towards the left shoulder. So using all the principles that we learned about direction, heart walls, and bundle branch block, we were able to prove that the patient was pacing from the right ventricle. So if you look at this ECG, the pacing spikes are a bit more subtle, but you can clearly see that in lead 2, there is a pacing spike preceding every P wave. Well, what about the ventricles? You can't really see ventricular pacing spikes in lead 2, but if you look at other leads like V2 or V3, you can see a ventricular pacing spike as well. This is called AV sequential pacing. You still see a left bundle branch morphology in lead V1, and so pacing is from the right ventricle. But if you look at leads 2, 3, and foot, we notice that they're now positive. And this denotes that we're pacing a bit higher up in the septum, close to the ventricular conduction system. And here's our last ECG, biventricular pacing. When a patient has heart failure, sometimes there's an electrical dyssynchrony between the right ventricle and the left ventricle. This means that the right ventricle and left ventricle are pumping at different rates, and this leads to worsened mechanical function, worse heart failure symptoms, and increased mortality. One solution to this is to place a third wire in the coronary sinus that overlies and paces the left ventricle. The idea is if you can pace the left ventricle and the right ventricle at about the same time, you can coordinate or resynchronize the ventricles. you can improve cardiac performance and in some patients improve heart failure symptoms. We can clearly see a ventricular pacing spike preceding the QRS in multiple leads including V1, lead 1, and lead 2. In this situation, we can't easily see two pacing spikes that are present because they're timed right on top of each other. But look at the vectors. We see a right bundle branch morphology signifying pacing from the left ventricle first. And we can see that lead 1 is negative. So the wave of depolarization is coming from the lateral left ventricle. Also note a negative QRS in leads 2, 3, and foot, showing that the wave is coming up from the inferior portion of the heart. So in this ECG, we have biventricular pacing with one ventricular lead buried in the septum and another CS lead that's overlying the inferolateral left ventricle.